Hello, guys. Hope I'm audible enough. Oh, yes, that's good. Bienvenue, monsieur. Je suis très content à ce moment. I hope I've practiced that very well. That's the French. Yeah. So for today, members, for those who are in the call, I see we are just having most just not takers, but which is also fine. So I believe as we wait for the rest of the guys to join us, I can right away give the floor to the big man, and I still have issues with pronouncing your name. Is it Ves? Yves? How do I read that? If okay, you'll just forgive me. Maybe Madame Lois can read the name for us. Sister Lois, are you there? Lois, you're there? Can you read for us his name, please? Yes, Lois. Read for us the name, please. This is a learning experience. We are learning. It's a bit noisy. Okay, that's fine. So, Brother Kalume, actually, I think you just teach us how to pronounce. We are so much used to English, so double EV, it's very hard to read.
Yeah, so double E is like Eve. The S is silent.
Oh, Eve. Because
Yeah,
why?
I think French rules are a bit tricky.
Okay, because why is known as Igre. So it was really,
Oh, yeah, in French.
yeah,
Oh, yeah. So if if you are pronouncing it, you are saying it alone, you will say Y. Because it is a Greek I. That's why we say it is a I used by Greece. I think Greece people that like I Greek I can say something like that. But it is just a I. It is a I. It's a variant of I. Yeah. I know French words are tricky, so that's why I'm totally with you. Even if you pronounce it as Ives or you can you can pronounce it as you want.
yeah, it has given me hard time ever since last year,
Yeah.
just now. Ever since last year till now. Okay, it's Eve. Thank you for
Yeah.
that. Yeah, it's Eve. So we shall just keep taking it on as Eve. So, without further ado, allow me give you the floor, such that we use the time we have productively. So the floor is yours. You can take over the mic.
Okay. Thank you. First of all, I am delighted to be here today with you. I know we were supposed to do this session last Sunday, but just so I hope you'll just understand. So today we will be doing some live coding. We try to the concept we introduced last Saturday. So we'll try to open our IDE and write some Kotlin and try to see how we can do real world example with Kotlin and object oriented programming concept. So for those who were not there last Saturday, I try to present myself. My name is Yves Kalume. I am from DR Congo. That's why you will hear this French accent in my English. Actually, I work at Monaco, which is a fintech company. We are helping Africans in Europe to obtain to get bank account with just their passport and their mobile phone, with just their passport and their phones. So they'll just create their bank account and get IBAN, an IBAN account, and they can do remittance. So they can send money to Africa to their family just with their phone. And right now we are building a new version. We just released, so we have just released it yesterday. So you can get a USD account and Euro account from everywhere in the world. So even if you're based in Uganda, you can, and you want to get a USD account to do worldwide transfers, you can just download Monaco and create your account. So I am also a Google developer expert for Android. And if you want to get in touch with me, you can just copy this link and you'll find all my social media accounts. So I'll be happy to chat with you. So we can talk everything, not only tech, we can discuss about life. And I like reading books, so we can also talk about books and what you're reading. So without further ado, I open my intelligent idea. So last day we said that if you want to learn Kotlin, you can just download IntelliJ IDEA instead of downloading Android Studio, which is, I think it is very big for just learning Kotlin without building Android application. So if you want just to learn Kotlin syntax and yeah, writing basic scripts, you can just download IntelliJ IDEA, and we'll create a simple Kotlin application. So I will name it. Can someone suggest a name, or let's call it GDSC coding? Okay. So for now, don't worry about that. We just choose. So let's just choose Gradle as the build tool. So a build tool is just a tool which will help us to transform our code source into something which can be executed by the computer. So in our case, it will be executed by the GVM. So let's say it will be executed by our operating system. So if you are building an Android application, Gradle is the same tool which will help you to transform your source code into an Android application which you can run and share with your friends. So don't worry about it right now. We just check it here, and yeah, we'll also add sample code. And when you're building an application, you will be asked to set what we call a package name. So in let's say in programming, packages are just, you can see they are just folders. So for now, think of it as just like a path or something like a folder. And we can use, when we are building an Android application, we need it to be, or when we will deploy our application, we need it to be unique. So one of the most unique things on internet is a domain name. So if I have a domain name, even if there is another Eve Kalume, he can't have the same domain name, because if I got it, if I was the first to get it, so I will be the only one who will have this domain name. So what we do is we put the extension before the actual domain name, and we'll put our project. So I'll be the only one who will have com if Kalumi. So if I deploy my application on the store, it will be the it will be the only application with that package name or ID. So for now, I just put it right here. And yeah, that our project is initializing. Okay. It may take few time. I don't know why it is a bit slow. So while it is initializing our project, let's try to see what we have here. So you can see that when we create a new project, we already have some initial files. So you can see here we have our Gradle configurations. So for now, you should not worry about that. It's just it is specify our package name. So our you can say our it is also our ID. So the ID of our project if you want to deploy it on the web, and it also specified the Kotlin version we are using. For now, it is 2.1.10. So these are dependencies. Dependency are just code written by someone else, so we can publish it on the web or he can share it with us, and we will. So he will share it using Gradle. He will generate an archive that will be shared with us. We can also include this archive in our project using Gradle. And here we can specify the GVM version. The GVM is just the Java virtual machine which runs our code. So our project has been initialized. Here we have test. Should not worry about that right now. For that, for those who know about unit testing, things like that, this is the folder in which we'll write our test. So as you can see here, we already have an initial code written for us. It is a simple code. This is a classic hello world. I can say it is the first program to you can write when you are learning a new programming language. So if I run it, you see that it will just print hello world to the standard output. So now our standard output is the terminal, is our IDE terminal. So we can see here we have hello world. So now let's play and see what concepts we can apply when we are learning Kotlin. So the first things, so let's build a to-do list application. We want to be able to store to-dos and show them to the user. So the first thing we can do is to create a variable which will store our to-dos. We can say, so our tasks can be something like that, tasks. And in Kotlin, we can specify the type of variable. So I can say it is a list, and I need to specify the type. What is the type of values we will store in this list? I can say it will be a list of strings, and to create a list, we'll just do list of, and we can add whatever we want, but it must match this type we have specified here. So this is a list. So I can say, okay, as start, I have to do a live coding, and I have also to do some groceries. So I can say something like that. This is a list. And if I want to show what is in my list, I can use a loop to go through this list and show each element. So in Kotlin, we have different way of doing a list, of doing a loop. The first way to do, I can use a for loop and say, okay, for item in tasks, and I will say what I want to do with this item. So this is the simplest way of getting to a list and getting an element from a list while looping over it. So I'll just go through this list of tasks, and for each element at each index I will get the elements of the list. So I can just say, okay, print ln item. So this will print the elements and go to a new line and print second one. So if I run the code, you will see I have my two elements which are printed here. But what if I want to add few elements inside in my list here? So so I may do something like this. Okay, for those who have done language like PHP or other language, you can try to do something like, oh, I have a list, I can use this bracket and do something like, okay, at the 2, because this is the index 0 and this is the first index in programming or in computer science, we always start counting by 0. So I can do something like, okay, this is my last task. But you can see I have raised lines here because this list is not mutable. So I can change something from this list. I can just mutate its state. So I can add new elements, I can delete, I can modify it because it is a immutable list. As we saw last Saturday, we use val to declare immutable variable. So if I set var, I could modify my list and say, okay, maybe I'll change and initialize a new list with all the elements here. So I can do something like this, okay, and create a new list. So I can copy this list and create a new list. But lists are kind of special because even though I set this as a mutable variable, I need to set my list as a mutable list. This list is by default immutable, so I can't modify its element. So I can put back my val here, and here as the type of my list, I will say it is a mutable list. And here I also have to change something like that. And now I can just set, you can see here the red line have disappeared. So I can just add a new element to my list. And there is a function to do this without this bracket. I can just say something like add my new task. So, and if I run the code, you can see that this this last task is also inside my list. And yeah, this is how we can play with list and do many operations. We can even uh, go further. So let's now try to add, as you can see here, we have just one function in our code, but in a big application, we need to have a good structure of our project because as it grows, it may be difficult to manage. So what we can try is to have different functions for different operations in our or on our list, on our tasks. So we can have one function which will add a task to a list. What I can do something like this. Okay. And I will pass to this function the list of tasks. Since I want to modify it, it needs to be a mutable list. So it will be this one. And I can say, okay, this is the new task I want to add to my list. Okay, it is a string like this. And okay, and to this task, I will just add this new task like this. And I can also have one function to just show elements of my task list. So I can do something like, okay, I have my mutable list here and I'll print element. So there is also a kind of special function to list, to loop it, to loop over it. Instead of using for, we can use this function called for each. So for each element in the list, I will just print it. I'll just print the element. So we have a kind of special value here. So later we will see why this works. And as we saw last Saturday, this is the kind of function which take another function as parameter, and it is called a high order function. So this is a way to show to loop over the list and print each element. So here instead of having these operations here, I'll just say okay. First, I need to add a task to my list. So I'll just do something like this and add a new task. Okay, my new task like this. And after that, I can just show all my tasks. Great. So the new tasks have been added. And the next step, what we can try is to improve our program. Let's say I want to ship this and give it to a new user. So he will not be able to add a new task to the list because I set all the tasks inside my code. What if he needs to add new tasks to the list? So in Kotlin, there is a way to get user input. What we will This is what we'll try to do right now. So the first thing we can do is okay, we don't need to set tasks for the user, we let him to do it by himself. And what we can do is to okay, let's get user input. So I can say okay, this is the user input. And to read so to get input from the user, we can use this special function called read line, something like this. Okay, this will contain the user input. And what now we can do is to add this input to the task list. And you can see there is a red line here. If we go over this variable, we can see that the type is string with this question mark. That means these inputs can be null because the user may just try to hit enter without setting a new value, and this can be null. And as I said in the last session, Kotlin is a null type, a null safe. So Kotlin is by default null safe. That means you can't. It is very hard to have this null pointer exception we used to have in Java because we can't even compile this program if you don't manage these errors. So what I can say is okay, this I have to check before adding the task to the list. I have to check if it is not null. And if it is null, we'll just show the user that we can add a null value to the list. And as you see here, we even omit the type because Kotlin has what we call type inference. It will just try to see what will be the type. And by default, when we get input from the user, it is a string. So what I'll do is to check first if user input is not null and then add it here. And you can see that the red line has disappeared.
Yes, big man. Ah, man. Sorry, I was busy. Even right now, I'm in a meeting, please. Yeah, yeah, unfortunately, I'm in a meeting and I'm rolling it. So calling me, I'm chopping off the meetings. Okay, we talk via WhatsApp. Eh?
Input. What I can add is to tell the user that we are waiting for his input. What I can do is okay, I'll print to the standard output that you need to enter a new task. and this will print, but it will wait on the same line. It will not go on the new line because it is just print instead of print ln. Okay, I'll just run again my program, and you can see that we ask the user to enter a new task. So we just say, okay, my new task, and you can see that we show the task he has just entered here. But yeah, we if we run again our program, you can see that all the tasks he has added have disappeared. So what we want to do right now is to keep the program running instead of just asking for the user to set one input and then finish. We'll just tell our program to keep running until the user stop it. So what we can do is to set an infinite loop, which will keep asking the user for input for new tasks and show them as is setting them. So what we can do is we can use a second type of loop, which is while, and we'll just set this boolean to say that you'll keep running because loops always try to evaluate this operation. If it is true, it will run the code inside the loop. But so now we have set true, that means it will keep running because this value can change. So I will just put now the code inside this loop, and we'll add a new print ln here. Say that okay, your tasks are, and then we'll print them. So what we'll do is okay, you can say my first task. Oh yeah, so there is a problem with our program because the point is outside of the while. Since this will never stop, we will never reach this point. So what we have to do is to also put this inside the while. Each time the user says add a new task, we'll just print all of them. Okay, okay, I can say my first task, and he has one task here. I can say okay, let's add my second task. So here you can see we have two tasks, the first one and the second one. You can add as many as you want. So here we have seen how we can use for loops. This is for each. Under the hood, it uses the for loop, and we have seen how to use while. We have also seen how to use this list. We can use a list, a mutable list. We have used print. We have created new functions which takes parameters. And what we can do right now is to have a good organization of our project. So most of the time, if you build an application, a real world application, you need to have a great structure. And one of the recommendation is to use object-oriented programming. So how can we organize our project to have this kind of structure using object-oriented programming? So let's say we want to add some properties to our task. Maybe we want to, instead of having just the name, we want also to know if the task has been done. If so, what is the description of the task and all. We can add as many information as we want. But for that, if we only have this list of string, I don't really see how we can add new properties like a boolean to see if the task has been done. It will be very hard. So what we can do is we can represent our task as an object. So an object in object-oriented programming is just a representation of something by with just value that are important right now. So what we can do right now is can create a data class because in Kotlin, if you want to represent a data, we can use data class. You can also use a normal class, which is good also. But yeah, let's just use this data class right now. And we can say that a class we may have an ID and it will also have a description. And so the description will be just be a string and it will also have a boolean to see if it is done. Okay. And now what we can do is when the user want to create a new task, we will just ask him for the description. And after that, we will set by ourselves. So by default, if he inserts a new task, it is not done yet. And the ID will just be the order of the elements in our list. So what we can do is update our list. It must now be a list of tasks. And when the user sets a new input, what we can do is to create a new task, we'll just instantiate our class. So we'll create an object and we need to keep track of the ID. So what we can do also is to create now the task manager. So it can also be a list. It can also be a class. So this time we'll just do class task manager like this. And inside we will have our tasks, which will be a list, a mutable list of tasks, and it will be a mutable list of. This is how we create a mutable list. And these two functions, we can put these two functions inside the list like this. And it will have access to our tasks. What now we can do is to update also this one. So instead of passing this list of tasks to the as parameter, we can just get it from the class. We'll just do something like so by default it's all if I say task, it will just have access to this variable. I can also add this like this. This keyword mean so I want from this class or this object, the instance of this class, I want to get this property. So I hope you are seeing what you are seeing my screen. And yeah, and then I will just add a new task. Here I have written because the type here is a string. What I can do, I can create a new task here, which will have a correct type, something like that, and the ID will be the index of the elements in this list. So what I can do is I can create a new index from the list, something like this, and I'll get the size. So if the size is 0, that means this will be the first element. So I can do something like this. The ID will be equal to index plus 1 and the description will be the description of the task we will pass in parameter. So it will be new task and is done will be false like this. And then we'll add the new tasks to the list. This is how we can leverage object-oriented programming to have a better structure of our code. So if I want to list all the tasks, I will just go. So I will remove also this because I already have access to this one, and I will just come and so I will just let the print here. Let's see what we get. And here now, instead of creating the list here, I will just create an instance of our task manager. I just do something like task manager. Okay. And what I'll also do here is just to insert the new input to the task manager and it will just take care of it and create a new task. I'll just do something like this and add task user input. And after that, what I can do is, okay, task manager show. And let's run and see what is the output. So let me just ask the user every single time. Okay, now we ask for a new task to the user. Let's say, okay, I have to write some codes. Okay, and my second task. So these are the tasks. Here you can see that even the class name and its properties are shown. This is because by default data class implements what we call a toString method. So by default it has this. We can even override it. So we can define a new implementation of it. This method will just print this class with all its properties and value. So this is the result of this method. So I can just come here and change how it behaves. So instead of calling the parents or the parent implementation, I'll just come here and update how it behaves. I'll say, okay, we need just to print the ID and the description. So here you can see that I don't use concatenation as in many programming language. I use the what we call string templating. I just put this sign in front of the variable and by default it will get the value. And I'll just say it's done. So for now I will not show it's done. I'll just say okay, what is the task? And let's run again and see what we get. Okay, my first task. And here you can see what we get now. So since we have implemented our own toString method, what we define here will be the result of the print of the Kotlin print. We'll just call this toString method. It will transform the task into a string. So this is how we can use object-oriented programming to have a good structure of our project. But from this main function, so let me just try to put this in different files because we can. I'll just come here to refactor and I can just say move. Okay. Okay. Here we have extracted our class in a different file. This is just to organize our code. I can also extract this in a different file. So here we only have the main function. But there is something we can do. Let's say someone is writing the code here. We are a team of different developers. One of one of us has created this class and can see that this list of tasks is public. So I can get it from here. If I come here on task manager and I do something like this, task manager, tasks, and I do something like this, uh, I can do, okay, mutable list of tasks. Or I can do something like this. Okay, I can come and remove all the elements. Remove all, and I say something like true, for example. This will remove all the elements in the list. But this task manager doesn't offer the ability of to delete some tasks. And because this property is public, everyone can do whatever he wants with our tasks. So we can use what we call encapsulation to hide this from outside world. So I can just add this private keyword in front of my variable to tell Kotlin that no one should access this directly. He needs to have it to manipulate it through these two functions, through these methods, two methods, instead of just accessing this list so that he can do whatever he wants. So here you can see that we have now red lines. That means you can't modify this list. You just need to use the two methods we have provided you. Okay. So if someone has a question, you can ask before we try to continue. I someone if someone has a question, are you good? Are you hearing what I'm saying?
Yes, we are following and we are good.
Okay,
Members,
great.
if at all there is anyone with a question, please feel free to ask and feel free to write in the chat as we proceed. Please feel free.
Okay, great. Okay, no question. Okay. So now let's add few more options to our program. So let's say right now what the user can do is just to add a new task. Maybe you want to set a new task as done, or just remove some tasks. We can add few options. So let's try to see how we can do that. First, I will try to just hide this. And when we start our program, we need to show the user few options. The first one may be okay. The first option may be add a new task. And we can have a second option which will be show tasks, and we can also have one to close our program. You can say, okay, maybe I want just to exit the program instead of stopping it. And and maybe we can also have, so this will be the fourth one. We can also have one option to mark a task as done. And we will tell the user to choose one option. Then we can get the user inputs, something like this with line. So now we need to add some conditions to see which code will execute depending on the user options. So I can add a if the input equals 1. So since the input will be a string, this one is I can compare a string with an int. So I need to set it as, so maybe I need to set it as an int, or I need to set this int as a string. But what I can do is to convert this string to an int. So I can do what we call casting. Casting is just the fact of converting one type to another type. So I can just convert a int string to an int to a like basic int. So here I can say we have this words, this dot has a red line. Maybe I can try to zoom in. Um, okay, let's do this. Maybe this is too much. So you can see there is a red line here. This is because this may be null. So I can just call something on this variable which can be null. If I do that, I can have this null pointer exception. And if the user is just using the app and the app will crash. So we want to avoid that. So we'll just say, okay, call it safely. This means if this is null, just return null. Don't do anything. Don't just crash. So we just tell our program this may be null. I know this may be null. So treat it as it. And inside inside this if, I'll just do the operation. So I need to add new task if the user input is one. If the user has choose the first option. So what I can do is, okay, you need to enter a new task. Please do it. I'll just do, okay, enter a task. And then inside we need to read again, to wait again for the user input. Since you want to enter a new task, I'll just call it task read line, and then I'll add the task manager this new task. Okay. And as I said, this may also be null, but let's skip. We'll deal with it after we are finished, because there is a nice way to deal with strings, which is a bit different with other type. Instead of just checking if it is null, we can also check if it is not empty, if it is not blank, if it's just like it is just spaces instead of uh, a real string. And we can also add an else if the input is equal to 2. Maybe the user want to see all of his tasks. What I can do is task manager and call show. And maybe he wants to mark a task as done. So if the input is 3, what we need to do, okay, let's do this. What we need now to do is to ask him for which task we want to mark as done. So what we can do first is to show him all his tasks. So we just show the task and to ask him which one do you want to mark as done. And then we'll wait again for his input. So he'll just pick it, he'll just set a task ID and read line again, something like this. And on the task manager, what we'll do is we'll need to add a new method which will help us mark the task as made, as done. Okay. And let's create a new method. So for now, we'll just let it as this and we say task ID. I know we need to convert it to int. What we can do instead of trying to check again, we will just do, okay, we can do this to int directly. This means this will be an integer or a null value. And if So else, this means this is the last option, or maybe we can say, okay, else if, so again, if the input is equal to 4, the user just want to, you want to exit the program. So what you can say, okay, goodbye, and we'll call this break instruction to break the loop. This will just end this loop. So as you can see here, we have just managed four options, but the user can even say, okay, I want to set 5 as a input here. Our program will crash because so it will do nothing. It will keep running, and since we don't manage when the user enter an invalid input, our program will behave in an unexpected way. So we need to deal with case where user enter an invalid input or something we haven't managed yet. So what you can do is to add an else here. This means, okay, whatever the user will enter, which will be an invalid instruction, we will just bring him here. So we just show him, okay, this is an invalid option. We just show him this is an invalid option, and we'll bring him back here and we'll show him again the options, and he will have to choose a right one. So now let's first manage this one. So here, instead of just trying to check if the value is not null, we need also to check if it is not empty, if it is not blank. So what you can do, you can add an if again here, and we'll see, okay, if task is not empty, so is not empty means it can be space. If we have space, this is not empty. But we don't want the user to add this as a task because it means nothing. So we want him to add a real word, something which have character. So we need to say if it is not blank, blank will exclude even spaces. So if something is blank, this is a blank string. So we will not add it to our list. And this also excludes null value. So we can say, okay, if it is not blank equal to true, can now add our task. And you can see that the red line has disappeared here. So we'll just say, okay, if it is not blank, that means it is not even null. Now let's add this new method called mark as down. So we can come back here to our task manager and add a new function called mark done. So we'll mark a task as done by getting its ID. An ID will just be an int, and what we will do, we will just go on our list and try to find. So there is a method called find on the list. A task. So we have it. It means the actual. So we will loop over the list and we'll see if so it will contain the actual item we have actually. So we'll go it and we'll get its ID, and we'll check if the ID match the ID we have just passed here inside here to the function. And then if it finds, so it will be uh, task. Let's call it found task. Okay. And we'll mark it as done. So we'll just come here to the list. What we will do is we'll just try to mark it as done. So here now we can see that we can't modify this. We need to change it to variable, to make it to make it mutable. So we instead of val, we'll use var. That means we can now modify this variable. So we'll just come here. You can see the variable disappear, and we'll set it to true. And here you can see that yeah, we have this. Since this, we can if we don't find any value, we need to deal with this case because we can enter an ID which is not already so an ID of the task, but the task is not already inside our list. That means this will be null. So we need also to manage this case. That's why we have this red under the dot. So as I said, Kotlin is something, so it is a very safe language. That means we can try to manage all these cases. So what I'll do, I'll just do something like this. You can see that it has disappeared. And yeah, let's update the print here to show also if the task has been done. You can say it's done and it's done, something like that. And then here we also need to say, okay, this may be null. What do you want to do? So if the task ID is not a valid integer, I don't want to go to my list and look for something which is invalid. So I first need to make sure that the task ID is not null. Okay. And now we have our program which is I think it is working. Let us try. Okay. Now we show all the options and ask the user to choose one option. So let's first try to enter any invalid options. I try to enter 8 and it says invalid option and it asks me again to choose to pick up one option. So I'll just say 1 and it asks me to enter a new task. So okay, my new task. Okay. And then show me again the list of options. So maybe I want to list all my tasks. I go to show. This is the second option. And you can see here I have shown the list of my tasks. So I have the ID, the description, and if the task is done. So let's try to mark a task as done. Okay, I have this. Since I have only one task in my list, it show me just one. So if I add so if I have like 10, it will show me 10 items. So it asks me which one I want to mark as done. So for now, I have only one. So yeah, I want to mark the first one as done. And now let's try to show it again. Now we can see this is done is now true. So my task has been done. So I can add even a new task again. Let's say my second task. And if I want to show them, you can see I have the first one which has been done and the second one which is not done yet. So what you have done here is just, yeah, we have tried to organize our project using object-oriented programming. So every part of our application is organized using a class and class and object. So for example, I'm building a task manager app. So I also try to represent it as a class. So this is a task manager. So in my task manager, I can also represent. So I will have tasks, and I'll also have. I'll also represent operations which help me managing this task. So I can have add task, show task, mark as done, and I can even add more operations like remove task and so on. But what is a task also? Using object-oriented programming, I may also represent this task as an object. So I can say, okay, for me, a task may have a name, so I need to know which task I'm going to do. A task may also have a time, so which time, at what time I will do it. It can also have a status, which means okay, is it done or not yet? So I can also represent it using a class. And in Kotlin, we can create a class by using the class keywords. So this means it is a class that can have some operations. And this class is okay. We can even represent data using this one. There is also a kind of special class, which is a data class, which is which is usually used to represent data. So this data is a data in our application. Since I need to, maybe I need to store it, I need also to show it. That's why by default, I have these two string methods which help me to show, to print a task to the screen. And I also have a few other methods which are implemented by default. For example, I can compare two tasks. So by default, you just go through all the properties and compare two, like all the properties from the two tasks I want to compare and to tell me if they are equals or not. So this is uh, how we can structure, we can organize our project using OOP. So I don't know if someone has a question, we can try to do a second example now to see some other concepts like abstractions we can use to know how we can use abstractions in the real world. We can use polymorphism and all other concepts related to OOP. Good. Someone have a concern about what you have built right now? Okay, maybe it is a yes. Okay, so what we'll try to do now, let's commence this. Let's just okay, let's do something like this. Or let's just move these codes outside this file. And we can also add this function called run. This will run our task manager like this. Don't worry about that. Okay, now let's see some like, useful concept when you are building an app using object-oriented programming. Let's say you are building an app to help managing a car, something for car stations. And since you are using OOP, object-oriented programming, you may want to represent a car as a class in our program. Maybe you can add something like this: class, car, and the car can have a brand, and a brand can be a string, and a car can also have speed, which can also be a int, and we can also set a default value. So by default, the speed can be 0. So we can also have some operation. With a car, we can accelerate, for example, can accelerate, rate. If you accelerate, that means we'll need to increase the speed. So we can do something like this. We can increase by 10. But since this is immutable, we can't modify it. To be able to modify it, we need to set it as var like this. You can see that the red line has disappeared. And if you accelerate, maybe we want just to print the new speed. So we can say, okay, this brand is have accelerated to speed kilometers by hour. So we can also break. Let's say, yeah, we can break and say, okay, this. car is braking. And what you can do now, let's say you want to test, you can just create a new car like this and you can say, okay, the car is, the brand is Toyota, for example. Since I have set this speed as a default value, I don't need to set it again. And if you can notice here, we have instantiated this class by using with a value because inside the constructor we have set some variable that need to be initiated when we are constructing our class. That's why I have set this model here. It is a Toyota. And what I can do, I can call few methods like this. Okay, I can call car and I can say, okay, I want to accelerate and then maybe I will brake. So I just call accelerate and brake. So let's run our program and see what we get as output. So you can see that the Toyota accelerated to 10 km per hour and it is braking after that because I called all the two functions. But something is tricky about this one because if we have this car here, we can do something like this. Car speed equals, I can even say equals minus and add this value. This is not safe as a program because this is not something we expect to have while we are building an application. So we can have a negative value as speed. This is done because this variable is public. So what we can do, we can use what we call encapsulation. Encapsulation just means to hide internal state of a program. So we don't need to expose this one. So what we can do is to remove it from the constructor and set it here inside. And what we can do is to set it to private. That means no one can modify this speed from outside. This is an important concept while you are building an app using object-oriented programming because you want to hide you want to hide internal state from the outside world to avoid something which is not the intended behavior. That means if you want to increase the speed, we only need to get to do it from the accelerate method. And we can even add some safety check. What we can do is you can do something like this. Okay, maybe for speed, we can accelerate only when under it is under let's say 100 km per hour. So we just we can add a additional check here, and in else what we can do is to say okay, if it is more than 100 we can say that you have hit the limit, something like this. This is the importance of this encapsulation concept because it helps us to control how our class is manipulated by the outside world. Maybe if you want to expose the speed, we can just create what we call a getter. So we have this a setter. A setter is a function which modifies this value, and a getter is just a function which helps us to get the speed, for example. So we can have what we call a getter, which will just which will help us just to get the speed. And now let's see how we can use abstraction to in a real world. Let's say we have electric car and we may have electric car. Say Elon Musk helps us to have electric car in our company. Can say okay, now let's add electric car and An electric car can also have this, kind of same method, but you can say, okay, this is an electric car, and it will also have a brand, which is a string, but we can say something like, okay, it is electric this time. And we can also have gas car. So we have electric and gas car. Okay, electric like this. But you can see that these two methods are the same inside the two electric car. And so even all the three methods, every electric car must have these three methods. We need to accelerate, we need to get the speed, and we need to brake. So for two of the car, so all of the car we can have, they must have this. This is a kind of contract we have with a car. So we must be able to accelerate, we must be able to brake, we must be able to get the speed. So to represent this contract, we can use what we call an interface. An interface helps us to set the contract between a class and the outside world. So we'll use so it's use what we call abstractions. So instead of having this car here as a class, what I can do, I will have it as an interface. This means I have a class, but I have a car, but I don't know which type of car I have. So I just say, okay, I need to have a contract for each class, for each car class I will have. So they must make me able to accelerate, and I must also be able to get the speeds, which will be an int. And I also uh, I must also be able to break. Okay, something like this. And to set this contract, I will come here and implement this interface. And you can see that I have some red lines here. This is because this method is, I need to override the methods from this interface. I need to implement them. So to implement them, I need just to set, okay, I need to set this keyword before override. This means I provide an implementation of this method from the interface. So I need also to add it here and also add it here over here. So I also need to add it right here, and I'll add the modifier here. Okay, great. So now I have all my cars respecting the contract of a normal car. So the contract is defined here. What I can do now is to create a variable of type car. I can just say, okay, this is my first car. The type will be car, and the implementation will just be, for example, I can say, okay, the first one will be an electric car, and it will be a Toyota, for example. And the second one can be a gas car. Oh, we can have Toyota electric. So the first one may be a Tesla, for example, and the second one may be a Toyota, for example. You can see that the type is car because those these two implement car contracts. So their type is also a car. So by default they are cars, even if we have electric and gas car. Both of them are cars. So maybe if I want, I can just, yeah, break, or I can also have this. I can have a function here. I can call it test car, something like test drive. I can test it. and it will have car as the parameters, and we'll just first call accelerate, and we'll get the speeds, and we'll brake, something like this. And what we can do, we can test the first car, which is car 1, and we can test the second one, which is car 2. So even though if we want, we can remove this one, you can see there is no problem. Continuous what we call inference. So you know, oh, this one is electric car and this one is a gas car. But what you can see here, these functions accept both of the cars. This is what we call polymorphism because a car can have mm, many forms as it wants, but since it has this contract of a car, it will be accepted by these functions. So these functions do what we call polymorphism. So if I run, you can see that our code can run just as a normal code. Yeah, we see the Tesla was so the Tesla accelerated to 10 kms per hour, and all the things are working great. But also one thing you can see is that this braking, yeah, are the same, and get speed is also the same. Why do we repeat ourselves? We can just write them at one place and just, yeah, can just keep them, but well, you can just write them at once and call them on both of the electric car and gas car. But with interface, we can write implementations. We just set a contract and the class need to implement them. So if we want to have a default implementation, we can leverage what we call inheritance. Inheritance is just the fact that a class can have children. So we can have a class with implementations, and it can be inherited by a child class. So I can have something like this. So in Kotlin by default, if I have this, so let's say we have a class called base car, which will have a brand because all the cars have a brand, well, which will have a brand, and what I can do. So let's define, because all of them also have the speed. So speed has just one implementation. I'll set it to private. I'll keep it as private. And I know that speed and brake are the same for both of the cars. Since this one implements the car contract, it will need to override it. But since I don't have the implementation of accelerate because it's different depending on the type car, I can I can't implement it here. So, but continue is keep complaining because I don't have the contract here. So what I need to do is to say that this class will not be used as it is. It needs to be inherited by something else, by another class. So in Kotlin, by default, you can't inherit from a class, from a regular class. You need to set it as abstract or open. So like if I say abstract, you can see that the red line have disappeared. So I don't need to implement it, and I can't instantiate it. So what now I can do, instead of implementing car, I can just use base car like this. And I need to override, so I need to override this one. Okay, okay, okay. I need to do like this. And since it needs to have a brand in the constructor, I can just, okay, what is it? Okay, as you can see, it is saying I can override this property from the brand parent because Also by default, this is a final. That means I can inherit from the class. What I need to do is to set it as open. Open means just it can be overridden by the children. It can be redefined. So we can redefine it over here. But as you can see, speed is I can have access to speed, but base car is a parent of this class. This is because I have set it as private. So in object-oriented programming, we have different visibility type. If I want this property to be hidden from the outside world, but be visible to the children's, I need to set it as public instead of private. That means children's class can access to these properties, but I can have access to it from the outside. Let's say from these functions. So now I think we are good. I need also to update the second one here, base car, and I can add override, and I will provide this branch to the parent. So since it's defined for it inside the constructor, and I can do something like this. Here you can see we have redefined. So maybe we can also add. Let me remove it. We will add it after that. So here you can see that, yeah, I have my car with default behaviors for these two functions because they are the same for every car. And in my electric car, let's say, yeah, it's different. We can accelerate up to 50, and in gas car, you can accelerate up to 100. And you can see that these functions will also respect polymorphism. For example, if I say, okay, this will take a base car, we can see that it's keep it is it's still correct, so it is not complaining. And when it comes to inheritance, some I can even override some properties which are already defined in the parent class. Let's say in gas car, I feel like, yeah, maybe the break may be different. So I can come here and redefine it again. I can say break, and here first it may call the parent one, the parent function, or I can just set my own behavior. I can say, okay, breaking gas car. And I can have something like that. I can redefine parent method as I like, as I want. So I can even run again. Okay, what does it say? Or maybe I'm having GVM. Okay, this is just something related to GVM. Maybe I need just to change the name of this one. Okay, get my speed. Don't worry about that. This is just some the I feel like the GVM is complaining, but it is just complaining about the name of the function. Okay, now we can see that, yeah, the implementation of break is different because I have redefined it inside my gas car here. But everything is keep working good. And Kotlin has also a so this I think this is the one of the last option we can have the last uh, topic we can explore. Kotlin also has a kind of special type which is called enums. Enum is just an enumeration which help us to enumerate like options or things. Maybe we can say, okay, we need to also to have fuel type for our cars. We can say, okay, fuel type. This may be a class, but since I know what are the fuel type, it is a set of options. I can define them as enums. So I can say, okay, it may be, yeah, it may be electric, it may be diesel, or it may be hybrid, something like this. hybrid, something like this. Okay, and this is enumeration. I know if I have a field type variable, it's maybe only one of these three. So I can have a different one. And thanks to enumerations, so I limit the set of options to these three. We also have what we call sealed class. So in Kotlin, we also use sealed class. Most of the time, we use them in Android applications to represent application state. And seed, as by its name, a seed class just means a seed class. So it means that a class with non-children. So if I say this is a seed class, it means that it can have, so I will have assign few children here. Let's say I have some action to the car, I can accelerate, can do something like this, accelerate, and this is the car actions, and I can say, okay, maybe I can also have a brake options, which is a car option. So if I set these two options, that means this class can never be inherited by another one. So this is it is sealed. It is limited to only these two options also. So we can put open keywords here and come and inherit it from a different class again. So at compile time, when you are writing your program, you already know that you can only have these two options as children of this class. So it is sealed to only these two classes. And it is really useful when you are building an application because you can represent your app state. For example, you can have you can say something like, okay, I have a screen which can have what we call a UI state, and the UI state can be, I can even have data class. It can be the first, so I can have a object. It can be loading. I can say my UI is loading. I can have a data class which will contain result. I can say if it is success, maybe it can contain some data. Okay. I can say, okay, the data may be type any and UI state. Okay, you can also have a since I don't have any parameter, I can set it as a sealed interface. It is also the same as sealed class because it has a limited uh, number of implementations. So I can also have, a object or a data object which represents an error, like as error which can contain a string as the message, and it will also have this. And this is useful because in my application, if I have a UI state, let's say, okay, I have here my UI state, which type is UI state like this. I can have a when operation which help me to, to manage all the cases of my when because I know. Uh, so let's say I initialize it later, something like this. Okay, let's say I want to deal only with these three cases. I can just, yeah, I know that if the type is error, it means I can have access to the error message. So I can say, okay, maybe I need to point the UI state error. And if I have the success state, I can have the data. So if you come here, I can see that I have access to data. This is a useful pattern. Maybe right now it may not sound obvious, but as you be building Android applications, you will see that it is the way to go when you are trying to represent UI state in your applications because it's safe and you already know what may be the type of your data and you will manage all the cases. I think we have explored most of the concepts related to object-oriented programming. I so if you have any question about this concept, or you have, or even about Android development, you can open your mic and ask them.
Thank you. Thank you, Mr. Kalume. Eve. We just call it, we just say
Yeah,
Eve.
well pronounced.
Yeah, well pronounced. Okay, that's good. That's good. So, members, anyone with a question? Mr. Johnson, Mr. Ben, Mr. Togumi, anyone with a question? If there is anyone with a question, please feel free to ask. If there is no one, I still give back the mic to you. Boss, let me give you back the mic because seems everyone is contented with this, and also recording the session for those who could have dropped out due to network issues. I'll be sharing the recording in the groups as well.
Well, thank you. Okay, I I think that's all I prepared to for my presentation today. And these are, like, the basic knowledge you need if you want to build an Android application. You must put your focus on object-oriented programming, because this is, the most important concept in software engineering. But I don't say it is the only one. It is one of the most important. If you if even if you are not doing Android development, you may need it if you want to to plan how to develop a software. Maybe you can try to model your project. Most of the time you use concepts related to object oriented programming, even for having a structure of your database. You also need to represent every element as an object. So yeah, this is an important concept you need to read about. And yeah, but it is simple if you understand the theory behind, and we can build very, very complex applications with this pattern.
Yes, yes, actually, thank you very much. You have really stressed out everything because I really used to have hard time implementing some of these things like interfaces, how to work with interfaces, and even sealed interfaces themselves. Actually, even should I call them the
Mm.
nums, the num classes?
Yeah,
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 exactly. They used to give me a lot of headache implementing them, um, playing with those methods, how to print them out as okay in a different meaning, like returning them in a different format,
yeah,
like other than you.
yeah,
The other, what format should I call it? Where you're having the ID. Okay, everything is in some sort of a box form. Okay, returned in form of a draw, in form of curl brackets where they give you ID equal to this and all that stuff. Because I was passing through them like during some online course of Meta Android app development
yeah.
course on Coursera. Yeah, that one there. Thank you so much. So I don't know what next, but actually you've done so much, and you've really given us good fundamentals, stressing out everything related to OPP. I don't know even how what I can add on, but literally you've stressed out everything that used to give me good headache, and it's good that at least I was recording the session. Yeah, this was giving me
Okay,
headache because without understanding these fundamentals here, the foundation, there's nowhere you're going.
yeah.
Yeah, so much. So Mr. Keith, Mr. Ben, please, if you're having any question, please feel free to ask. The session actually, okay, yeah. Unmute, please. Unmute.
Hello.
Yes.
Hello.
Yes.
I have no question really, but I just want to pass on a message of appreciation for the content that has been shared. It's quite a lot. It's quite rich in context. If we could have the video and catch up with this, it's really vital information. Just to say thank you for this. It was a wonderful session.
Great. Thank you for attending. So,
Yeah. Yes. Actually, that's great, Mr. Ben. The recording, I'll drop it. I'll drop it in the groups very soon. Mr. Keith, if at all you're having any question, please you can unmute. So if Mr. Keith is having no suggestions, that's